Okay, here we have a problem that looks at the risk from air pollutants. This is a factory that emits benzene into the atmosphere 24 hours a day at a concentration of 0.01 milligram per cubic meter of air. And children are exposed in this case for 300 days a year for 10 years. All right, the acceptable risk we know to be 1 in a million, or 10 to the negative sixth. What is the incremental risk, or what is the risk that's actually we're actually seeing in this scenario? Okay, so we're going to check and see if this risk, is it higher than the acceptable risk? Is it lower in this scenario? And then we can make a decision, management decision based on that. This is the kind of problem you might see on your homework or on an exam. Okay, so we know that the risk is the CDI, or the chronic daily intake, times the potency factor. So we need to calculate the CDI. We can get the potency factor for benzene from the table. CDI is something we need to calculate, and that equals the concentration of the pollutant in the air, which we know. Daily intake, we don't know how much air they're breathing every day for children. Okay, so we need to go to table 410 to figure that out. Exposure, we know the exposure, they're exposed 300 days a year for 10 years, so that's given. So that's going to supersede anything that might be in table 410. So we already know it from the problem. Okay, so we've got to use the data we know, and what we don't know, we'll go to table 410 to get that. Body weight, okay, that's something we're going to go to get that from table 410 to see what do they say for children. If they give a body weight for children, sometimes they use body weight for adults in that case of some of these inhalation calculations. Okay, it's always going to be 70 years of life. That's just the average life expectancy. Doesn't matter if it's a child or an adult. 365 days per year, that's just, our exposure is in 10 years out of, 300 days out of 365. 10 years out of 70, okay? That's how we get these in the denominator here. All right, so what we're going to have, we know our concentration 0.01. This intake rate, that's what we're going to get from table 410 here. So let me do this. Hang on, make this a little easier to see. Okay, here's table 410. And what you can see is that for inhalation route, we're going to assume residential. That's where these children are. We don't have that information for the others, so we're just going to assume residential. That the child's intake rate of air is 12 meters cubed per day. Okay, that's how much they breathe compared to an adult. We already know the exposure. We already know the years. And then for the body weight, they don't give us something specific for child, so we're going to use 70. Okay. And that would be the same for all of the others down here if it was agricultural or recreational, all right, that are further down in the table. All right, so given 70 kilograms and then the intake rate of 12 meters cubed per day, make sure our units cancel out. We're going to be left with milligrams per kilogram day. Okay, that's our CDI, milligrams per kilogram day. All right, so our risk then it's just the CDI times the potency factor for benzene. Go to table 4.9 to get that one. And we get an incremental risk of this 0.002 milligrams per kilogram per day times 2.9 times 10 to the negative 2, the inverse of that, kilogram day per milligram. And we get a risk of 5.84 times 10 to the negative 6. Is that okay? No, so that's not okay. That's too much, because remember our acceptable risk is 1 in a million, and this is 5.8 or almost 6 in a million people. So we need to reduce that initial concentration. Okay, so part B of this problem is just taking it in the other direction. So now we know we need to reduce it to what concentration must the factory reduce its benzene emission to attain that acceptable risk of 10 to the negative 6, or 1 in a million. Okay, so we need to now calculate a new CDI. New CDI is going to be our acceptable risk divided by our potency factor for benzene. And new CDI is 3.45 times 10 to the negative fifth. So we're just working backwards. Our new concentration then is our new CDI, this one right here, okay, times the body weight of 70 kilograms, 70 years of life, and 365 days of year, divided by the daily intake, 12 meter cube per day, and exposure of 300 days a year, 10 years from our word problem. Okay, everything's still the same in this scenario. We're just now trying to work backwards to get what the new concentration has to be. Okay, we fill those in. Make sure our units all cancel out. We got to end up in milligrams per cubic meter. All right. And that's what we have here. So it's 1.71 times 10 to the negative 3 milligrams per meter cubed is what our new concentration is going to be, which is, remember the earlier was 0.01, so that was too high. So this is about 5 to 6 times less concentration, 0.0017 milligrams per meter cubed.